Hi everyone, in this video I'm going to review the in-class activity covering chi-square. This process is pretty easy if you just practice a few times. Also memorizing the little table I'm going to show you that we practice in class is also going to help you solve this problem as well. So here are the steps of solving chi-square. I did write them down. If you'd like to write them down, go ahead. Throughout this video I also encourage you to pause and then do the math. I already have it written down. However, practice the calculations on your own and then double check with what I got. So just to review really quick, the steps of doing chi-square. This is essentially what the table is saying, but in words. So the first thing you're going to do is add up all of your offspring to find the total amount of organisms you're dealing with, whether it be peas, animals, whatever. You want to find your total offspring that you have. Then you're going to identify your observed numbers and make sure to write them down. Then you'll identify the fractions or the ratios. This will make more sense once we kind of start doing the math. And then you're going to multiply the fraction by your total number, and this will be your expected value. And then you'll take your observed number and then subtract it from, you'll do observed number minus expected number and write that value down. This doesn't matter if the value is negative because in the next step we are squaring it, so it'll end up turning positive anyways. Then you're going to take your observed minus expected number, and then you're going to square that, and then divide it over your expected number, write down that value, and then you'll add up all of the values in the last column, which is represented by O minus E squared over E, and this is the number that you'll use to look at the p-value on the chart. The p-value is what determines if you accept or reject the null hypothesis, not the total added up number you get when you add up all the different values together. All right, so first thing I'm going to show you is this chart. When you start doing the test or practice questions, I really encourage you to write this chart down. Write down O for observed, E for expected, and then O minus E squared, and then O minus E squared divided by E. Again, O is observed, E is expected, and the column's really nice because all you have to do is move from kind of one column to the next. So the chart doesn't require a ton of math, it's a lot of repetition, but once you find your values, you can use them in multiple areas. Okay, the next thing, so here's what we're working with. The parents were round and green and wrinkled and yellow. The first set of gametes, the F1 generation, ended up being round and yellow. So then they crossed them again, and this is what the ratio they got. They got 315 round yellow, 108 round green, 101 wrinkled yellow, and 32 wrinkled green, for a grand total of 556 seeds. The first thing that I want to make a note of is the total number. In a problem question, they're not always going to give you this total, so it's really, really important that you write it down yourself. So again, this is your total. The next thing that you may want to label is this row of numbers, or this column of numbers right here, and these are your observed numbers. Meaning when you went out in the field and you crossed them and you saw what the progeny was, this is what you ended up seeing. 315 round and yellow, so on and so forth. So you can write here observed, numbers, and then here on the right hand side you have your ratio. With this, you're not always going to be given a ratio. In this instance you were, because in this little blurb up here it said that does the population meet the expected 9 to 3 to 3 to 1 ratio, but again, you're not always going to be given which one's 9, which one's 3, which one's 1. So a quick way of figuring that out, so I'll write here, this is the expected ratio. Again, it may not always be given. If it's not, take this observed number and then divide it by the 556 or your total number. So take your observed, divide it by your total, and then that should give you some kind of fraction, some kind of decimal. Or you can just kind of glance at your data set and see which one is the largest. That will probably be your 9. The two that are pretty similar in size, your two middles, will probably be your 3/16, and then your smallest one will likely be your 1/16. So again, just looking at like rough estimates in size, you don't necessarily have to do the math, but if you do, to double check yourself, that's fine too. And then again, this is out of 16. Okay, so now that we have that, we're going to move on to filling out some of our chart. So first thing you're going to do is write in the O column or the observed column. So again, the observed numbers are your 315, 108, 101, and 32. So write those values down here. Okay, and then once you've done that, the next thing that you want to look at is your expected numbers or your expected ratio. So in order to do this, you are going to use your expected ratios from over here. So you're going to use this column, and you're going to take your 9/16, your 3/16, and then your 1/16, and you're going to write all of the ratios or all of the fractions, just write them down. This is what you're going to start with. The next thing you're going to do is you're going to multiply it by your total. 56. And then once you do the math, write down your answer. And then one quick note that I want to make about doing the math and multiplying fractions times a whole number, stuff like that, is this is not always going to give you a whole number. And because it doesn't always give you a whole number, what we do is we round. You're going to round up. So you must have a whole number in order to do this, because you don't have a fraction or a part of a p. You need a whole p or a whole whatever organism you're working with. You don't have fractions of an organism. So make sure you round up, use your regular rounding rules. 0.5 and above is up, and then 0.4 and lower is round down. Okay, so once you get your E, or your expected values, this is how many in a set of 556 seeds, you would expect 313 of them to be that round yellow, 104 to be round green, 104 to be wrinkled yellow, and then 32 to be wrinkled green. So that's what you're expected, that's what those numbers mean. The next thing that you're going to do is the next column, so O minus E. And again, like I said before, the nice part about this is you basically are just reusing your values. So you can scoot all of your O values right on over to the third column, and you can do the same thing for the expected column, and you're just going to subtract the two. So again, this process isn't necessarily super hard, it's just a little bit tedious, but you'll definitely get faster once you kind of understand the steps and memorize how to do the chart. Okay, and then once you have those answers, you can just write them down. You'll see that these two answers right here, -3, are negative. That's okay, because when we move right on over, we're actually taking the value that we just got and we are squaring it. So again, just take all of these values that you got, 2, 4, -3, -3, move them over, and then square them. So that's why it doesn't matter, because they'll end up positive anyways, which is nice. And then you'll take those values. So we have 4, 16, 9, and 9. And then once more, we are going to take the value that we just got, so your O minus E squared, and we're going to move those over to the very last column, and we're going to divide them by our E value, or our expected value, which we already wrote down. So you're really only doing a couple calculations throughout this whole thing. It's just making sure that you keep your numbers organized, and that you don't accidentally like mix them up or change them. Okay, and then you'll just divide these. And then write down your answers. I like to go 5 decimal places. This is not necessary. You can pick as many decimal places as you want. Try to go for at least 3 or 4, just for good measures. But I like to go with 5, but kind of go with what you would like, what you prefer. Okay. And then your final step is to add up all the values together. So all of these values here in purple that I got, you'll add them up to get your final value, which comes out to be 0.51031. And don't forget that this is the number that you use for the p-value chart. Okay, so once you have your number, you're going to go down to this chart, and she will give you this on the exam. Don't worry, you don't have to memorize this. The only thing you do need to memorize is how to read this chart. So we have a bunch of decimals, basically percentages. We have 5%, and then everything lower than 5%, and then everything to the left of it is greater than 5%. The one thing that you need to know about this 0.05 mark right here is that anything to the right of it, you are going to reject. Anything to the left of it, you're going to accept. So basically this is saying with like 5% confidence, like statistically, anything lower than 5, they think that something else is going on, and further testing must be done, where if it's above that 5% mark, they will typically accept it and say that, the difference is because it's not the exact expected ratio we thought we were going to see, it's just due to random chance. And that random chance could be just the individuals that you selected instead of selecting the peas and the seeds on the right half of the field, you went to the left. It just is due to random chance, noise, whatever you want to call it. So again, anything to the right of 5% or 0.05, you reject. Anything to the left of it, you accept. In statistics, we usually say if P is low, meaning less than 0.05, reject that hoe. So again, anything lower than 0.05. And she will give you this table. You just need to be able to mark where this is, because she won't necessarily give you the red line. She'll just give you the regular table, and then you need to be able to memorize where this red line is and where the cutoff is. So the last thing that we're going to do now that we have our final answer here highlighted in yellow, the 0.51031, we're going to calculate the degrees of freedom. And to calculate the degrees of freedom, all you're going to do is take the total possible number of combinations. So up here would be your combinations, round yellow, brown green, wrinkled yellow, wrinkled green. So you're going to take your total number of combinations and you're going to subtract 1. So in our case, we're going to take 4 combinations minus 1 would be 3. So then when we are looking at this chart, we need to be looking here in this third column. Okay, so once I have identified which column you're kind of looking at, so you're again looking at, or excuse me, row, you'll be looking at all the numbers in this row right here. Then you need to look at your value that you got, 0.51031, and figure out where that is located on this table. For us, it would be right about here in between this little area, where you have 0.216 and 0.584. So it's pretty close to that 0.9, pretty close to this value right here. So again, if you turn those into percents, you're saying 97.5% and 90%. So again, it is on the left of the table, on the left of that line, so we would accept our null hypothesis. And our regular null hypothesis is that the expected observed progeny should be a 9 to 3 to 3 to 1 ratio. Any variation is due to random chance or noise. So we would say that we accept our null hypothesis, and that again is because the p-value is between that 0.9 and 0.975, which is greater than 0.05. So about a 90 to 97.5% for that value. That's how much confidence we have. There's a better statistical answer for that, but for this class, all you need to know is everything to the left is accept and anything to the right is reject. You can also remember it as R, reject, and right. So both R's, anything to the right of 0.5 is reject. Alrighty, and then here's a cleaner but pretty similar version. Again, just practice doing the chart, the OE, O minus E squared, O minus E squared divided by E. Just kind of practice that. Make sure you are able to fill out the chart, fill out the different values, keep your math pretty organized, round up, and don't forget that degree of freedom, because that will be important when you're looking at your p-values. I hope this video was helpful. Of course, if you have any questions, feel free to reach out, and thank you for watching.